In this lesson, I want to look at the actual process used to perform an operating system installation. However, before I look at the process for Windows Server 2012, I'm first going to look at the process used for Windows Server 2003 R2 and the previous versions of Windows Server, because it actually changed a great deal from Windows Server 2003 to Windows Server 2008. If you look at the media for Windows Server 2003 or any other version such as 2003 R2, Windows 2000, you'll see a number of files on the CD, and there's some boot code as well to enable a physical server to boot from this media. If I actually look at the detail of this, the i386 folder contains all the various files that make up the operating system in a compressed format. And essentially what happens when we install the operating system are these files are copied over and then installed after being expanded. This is a virtual machine undergoing a Windows Server 2003 R2 installation. You can see it's booted from the media. It really has a DOS type interface. It's loading various drivers, and that's going to actually perform the Windows setup. This is all text-based installation module. It's performing some basic scans of the operating system, and now I can actually go and perform the install. Read the license, select the partition, perform a quick format of the partition, and then what we'll see is it starts copying files to the disk. Now this process takes a very long time. You can see in the bottom right corner, I can see the name of the file that it's currently copying, and will then expand that file out. As the operating system got larger and larger, this process would obviously take longer and longer. And it's not just the copying of the files. Once those files are copied, there are hundreds of different subsystems in the operating system that actually have to be executed to set up the various registrations of components, the registry configuration, and other setup routines. This is why it takes so long to install an operating system. And many organizations would actually use an imaging technology. So they would perform an installation such as I'm showing you here on a physical box or maybe a virtual machine. Then they would run something called a sysprep process. So every operating system installation running a Windows OS has unique information, such as a security ID, a GUID. And these values uniquely identify specific installation of the operating system. Sysprep removes these identifiable values to enable that operating system to then be duplicated. And it also performs other routines to allow the OS to be duplicated. So organizations will perform this installation once, run sysprep, which is actually part of Windows Server 2012, which will then ready the OS for duplication, shut that down, and capture the content of that machine to a file. A familiar program was something called Ghost that enabled this imaging. Well, as the operating system has evolved, Microsoft have actually adopted this technique in their own operating system deployments. The concept of taking each individual file and copying it really is no longer practical. So instead, if I look at a Windows Server 2012, this is now the content of the media. So initially this looks very similar. However, there is no i386 folder. Now, part of that reason is obviously Windows Server 2012 is 64-bit only. There's no AMD64 folder either. Instead, we have this sources folder. And there are some files in here, but they're not compressed, and these are used for part of the initial installation. The key files we're interested in are boot.wim and install.wim. And what Microsoft is actually doing is they are performing that initial installation of the operating system in their own environment. They are running sysprep and then capturing it to their own Windows imaging format, or WIM. So in this WIM file is actually a block-based capture of a deployed Windows Server 2012 operating system. In this command prompt, you can see I've copied the two WIM files from the Windows Server 2012 media to this temporary directory. I can use the DISM command that I previously referenced for use with things like patching and injecting drivers to actually query a WIM file. So I'm just going to say get wiminfo, the name of the WIM file, which is install.wim. You have to run this from an elevated command prompt. So for example, to get an elevated command prompt on a local box, I might go to the start. And if you right click on the start, you get this nice little menu of some key commands. So right there we have a command prompt admin. So that's a great way to quickly launch an elevated with administrator privileges command prompt. So what you can see here is this block-based imaging format actually contains 4 different images of Windows Server 2012. It contains standard core, standard server with a GUI, data center core, and data center with a GUI. You'll notice it has a size for each of these images. Notice the core is around 4 GB smaller than the server with a GUI version because that contains the management infrastructure, the management tools, and the graphical shell. What is interesting, if we go back again to my directory, notice the size is only 3 GB, yet it seems to contain nearly 36 GB of actual content. The reason for this is the Windows imaging format actually does a single instance store. And even though we have different versions of the OS, essentially Windows Server Standard and Windows Server Data Center are identical, and Windows Server with a GUI contains all of the code that's also present in Windows Server Core installation, which means it only has to store all of those files once in this Windows imaging format. Additionally, it does use compression, and there is even duplication of files within a single installation. So this means that I can take those 4 different versions of Windows Server, install them in a single Windows imaging format, and still have less than half of the disk space of just a server core installation. So now what happens is when I actually go and perform an installation of Windows Server 2012, which I'm going to show you later on, it's actually going to take the content of this WIM file and lay it down on the boot volume you specify during installation. So it's no longer thinking of copying file by file and then running installation and setup routines for each component. It's basically laying down a fully installed and configured image of Windows Server 2012. And then all it has to do is some uniqueness operations to give it a SID, to give it a GUI, a machine name, etc. So this is really how the installation got so fast from that jump from Windows Server 2003 to Windows Server 2008. And you would have seen that same improvement moving from something like XP to Windows Vista. Windows Vista also leveraged the Windows imaging format. This concludes the lesson on the basic mechanisms of the installation process.